All right, we're back. We're on page 8 of notes 1 of Calc AB, and we are taking derivatives for some practice. So let's take a look at this one. So this is kind of interesting because it's radical, but it's also radical of a product. So what we can do is we can rewrite this thing. So I'm going to rewrite it as radical 12 times radical x to the 7th. But of course, radicals are terrible. So we're going to rewrite this as radical 12 times x to the 7 halves. Now we're going to take the derivative. So I'm going to call it dy dx. dy dx, the rate of change of y with respect to x, the instantaneous rate of change of y with respect to x. That's what we're finding here. So constant multiple, radical 12 times, what are you? It's supposed to be a 7. 7 halves x to the 5 halves, which, like, I don't know how the calculator is going to run. So radical 12 is actually 2 root 3. So maybe this will look like 7 root 3 times x to the 5 halves. That's my guess as to what the calculator will do. It doesn't matter. We're not like beholden to the calculator, but you want to see. All right, so the only thing about this one that I think is meant to be tricky is that the variable is t, right? And the function is named h. So I'm going to call this h prime of t. You might also choose to call it dh dt because h is the dependent variable, t is the independent variable. So that's how you would write that. Either one is acceptable. It's all power rule. This, I think, is probably like a position function for like projectile motion, like you shoot something up. You'll see maybe later in the class as to why I think that's the case, but I think that's probably it. Like you might recognize, you may not recognize it at all, in fact, but this is sort of the acceleration and in due to gravity, feet squared per something. Uh-oh, somebody should review their physics. All right, so it's like I literally don't remember, so I'm not gonna come up with it. All right, let's take a look at this. So given that v is equal to pi r squared h, find dv dr. So interesting. So v appears to be a function of r and of h, like two different variables. We want to find dv dr. So r is the independent variable, which means everything else in there is just a constant, like some arbitrary constant that we don't necessarily know. Pi is definitely a constant that we know. H is just a constant that we don't know. So the derivative here for dv dr, you really got to focus on your notation. If r is the variable, we'll get pi times h is just like a constant multiple, and then times 2r. So we get 2 pi r h. If we go back and do the problem again, as if h is the independent variable, we're actually going to get a different answer. So dv dh is going to be, so h is the variable, so pi r squared is the coefficient in this case, just constant, and then the derivative of h is 1. So we actually just get this. That's our final answer. So it depends. You really have to look at what the variables are. So I don't know if it better illustrates it, but to continue illustrating the point, let's take a look at this. So given that volume is equal to 1/3 pi r squared h, so that's like a cone, I think, and that both r and h are functions of t. What does that even mean? So what that means, so both r and h are functions of t. That really means that, like, for all we know, r could be cosine of t. We have no idea. It's a function of t. For all we know, h could be like 5t cubed minus 8. We don't know. So what we're going to try to do is find a formula that will give us dv dt, the rate of change of v with respect to t, in terms of r and h. So it's a little weird. So this means, like, you really have r of t and you really have h of t, which means the derivatives are r prime of t and h prime of t. That's what's happening here. So this is actually a product. So dv dt is going to be so pi over 3 is just hanging out. So let's leave that. First, well, what's the derivative of h if h is a function of t? It's either h prime of t or dh dt. I'm going to write dh dt, mostly because I wrote dv dt. And you want to, like, I find that you want to keep your notation consistent throughout a problem. So if you go dv dt on one of them, all of them are going to be d whatever dt. in my book. It's not, and my book's not necessarily the only book on that subject. So first derivative second plus second, which is h, times, well, now I need the derivative of r of t squared, right? So let me do that down here. d dt of r of t squared is just r of t times r of t, which is going to be first, which is r of t. Derivative of the second is r prime of t. And then plus second, which is r of t. Derivative of the first, which is r prime of t. So we end up with 2r of t, r prime of t. So that's the derivative of r squared. So of r of t squared. That I had to squeeze that in. So here, let me just like review. We had pi over 3 is your coefficient, then quantity. First is r squared, derivative of the second is dht, plus second, which is h, derivative of the first. So the derivative of the first we just found is actually 2r and then dr dt. So is there anything we can simplify? Like, you know, you can take an r out, which is fine, but it's not really going to make anything look all that much better. So I'm actually just gonna highlight this and say that this is my final answer. So this is it's really important to keep track of what your independent variables are, right? So for this problem, the independent variable is dt as well as t, right? So it's the rate of change of volume with respect to time. So it's not dv dr, it's not dv dh, it's dv dt. Well, I keep saying time because t is usually time, and you'll see later in life, it's almost always time. But that was a more complicated problem because the variables were actually functions of some third thing, a parameter really, that related them. So what I'm going to do now, I guess, is check as much as I can. I'm going to check these on the calculator and see how our answers compare. And so this is still the last problem that we were doing. So I want the derivative of the square root of 12x to the 7th. And x is the variable. Wow, whoa, I was not expecting this answer. So 7/3, and then it's x to the 6th. Why did it do this? Let's take a look at this. What if I do square root of 12 x to the 7/2 with respect to x? Because that's what we actually did. Now, why are these the same? Well, x to the 6th divided by x to the 7/2 is x to the 5/2, provided x is not equal to 0. So the calculator, I don't know why it shows that. That is crazy. Not what I was expecting, but anyway, we got it right. So let me go back in the notes. I'm gonna highlight that because we definitely got it right. And then the next one I have no doubt that we got right, but I'll do it anyway, just to like illustrate, right? So negative 16t squared plus 42t, what? 42t and plus 8 with respect to t. Okay, so it's really important here that you use t as your independent variable, right? So if we had accidentally said with respect to x, the answer would be 0 because there are no x's in here. So as far as the derivative is concerned, everything is a constant. So this will actually give me 0. When you get like suspicious zeros as your derivatives on the calculator, always go back and check your variables because I almost guarantee that you will have done one of the variables wrong. So so for the next thing here, let me do the derivative of pi times r squared times h with respect to r, right? So r is our variable. So we get 2 pi r h. What if we change our independent variable to h? Now we should just get pi r squared because h is a variable, pi r squared is a constant, and we do get pi r squared. So we did a really good job here. I don't think there's a way that I can like tease the next answer out of here. Well, maybe. Let me try this. Let's do this may not work. Pi over 3 r squared times h. Okay, so what I want to do instead of r squared, I want to do r of t squared. And then instead of h, I want to do h of t. So like I'm kind of like making it a little more explicit that t is the independent variable. And let's find the derivative with respect to t and see what happens. Let's get, let me factor, I guess. Okay, so I get pi over 3, I can see. It factored out an r, which I remember mentioning that we could do, and it gets 2h dr dt, perfect. And then it gets dh dt times r, which is also what we got. So we actually were able to get the calculator to spit out that answer, which I didn't know that that was necessarily going to happen, but I mean, I'm happy it happened. So I'm going to go back to the notes so that you can take a look one more time. And then I'll wrap up this video, and obviously I will come back in the next video and do even more. So a key thing here is when we're finding the derivative of like r squared, we really have to look at it as r times r and then just product rule it. We're gonna find a way around that, but for now, that's what we need to do. And I know like it's really annoying when you just know that coming down the road, there's gotta be a better way. And there is, but first become super proficient at this and you will have no regrets about that later on. So I'll see you in the next video.